this example, we're going to think about association and confounding again, but this time we're going to actually consider some data. So the question is, does playing in front of a sellout crowd at home lead to better performance? And we're going to consider the 2008 to 2009 record of the Oklahoma City Thunder, which is a professional basketball team. Okay, so we've got two different variables here. One is whether the game sells out or not, is a sellout crowd or a smaller crowd. And then one is the outcome of the game, the wins and losses. So obviously the outcome of the game, that's going to be the response variable, right? That's what we really care about, is whether or not the team wins. So that's going to be our response. And then whether it sells out or not, that's going to be the explanatory variable. So you can see both of these are categorical. Every game is being classified as a win or loss and being classified as a sellout or smaller. So what we have for our data is just a table of counts. And we want to know, is there an association between the explanatory and the response here? So there's actually a couple different ways to calculate it, but I think the easiest is to think about the explanatory variable, which is sellout crowds and smaller crowds. And for each of those different categories, to think about what is the probability of winning, or the estimated probability based on this sample. So if we look at the sellout crowds and we want to look at the proportion of wins, we have for the sellout crowds 18 games total, and 3 of those were wins. So the proportion of wins was 0.167 or 1/6. For smaller crowds, if we look at the proportion of wins here, so we had 23 games that weren't sellouts, so that's going to be our denominator. 12 of those were wins, and so we end up with 0.522. So the answer to the question, is there an association, is yes, because knowing whether or not it was a sellout crowd or a smaller crowd helps you to predict whether or not the Thunder won, right? For sellout crowds, their chances of winning were much lower than they were for smaller crowds. So this is an association, but it doesn't go in the direction that we thought, right? We might have thought that playing in front of a sellout crowd was an advantage, but here it seems like it isn't. It actually has the reverse association as we might have expected. So take a second here, pause the video, and think about what explanations there might be for this association. And I can think of at least 3. See if you can come up with 3 explanations. So one of them could be some kind of causal relationship. So maybe there's something about like the noise level and the pressure of playing in front of a sellout crowd that actually aren't helping the Thunder win. Maybe for this particular team, the noise level and pressure of playing in front of a big crowd is actually a disadvantage. So that's not what we would think. You think of like having an advantage of having a big crowd at a home game, but that's possible. Maybe for this particular team, there is some sort of causal relationship there. Another possible explanation is that we have confounding, right? This is not an experiment. We're not randomly assigning some games to be sellouts and some games to be smaller. And so you could have some kind of confounding variable. And people who know a little bit about sports may have thought of this one, that a potential confounding variable could be the strength of the opponent. And we'll look at that more in a second. One last explanation to think about, we're not going to talk a lot about it today, but just to get it on your mind, is that maybe this is just by chance. So it's possible that this difference of proportions that we see, 0.67 and 0.522, could be due to chance alone. So I wanted to mention this one because obviously in this class we're in the habit of ruling out a by chance explanation before we draw any conclusions. We don't actually know how to do this just mathematically yet. That's what we'll talk about in Chapter 5, is how to determine the statistical significance when you have 2 categorical variables. But for now, I'll just go ahead and tell you that this association is statistically significant. So there must be some other explanation besides just chance. So let's revisit the idea of confounding. So I'm going to draw our little diagram here. So we're interested in the relationship between a game selling out and there being more losses, right? That knowing that the game is a sellout allows you to predict that the team is more likely to lose. So in order for the strength of opponent to be an actual confounder, it would have to be related to both of these things. it would need to be associated with whether or not the game sells out, but it would also need to be associated with whether or not the Thunder loses. So we're going to do the same sort of calculations that we did earlier, but we're going to kind of do them twice. So let's think about strong opponents versus weak opponents and how that's related to the other variables. So the description says, of the Thunder's 41 home games, 21 were against teams that won more than half of their games that season. And that's what we're classifying as strong opponents, teams that won more than half of their games. Of these 22 games, 13 were sellouts. So if we look at the strong opponents and we calculate the proportion of the games that were sellouts, we do 13 out of 22, which is 0.591. The second paragraph here says 19 games were against opponents who won less than half of their games that season, so weak opponents, and of those 19 games, 5 were sellouts. So if we look at the proportion that were sellouts out of these 19, we've got 5 out of 19, which is 0.263. So because this is not the same likelihood, right, the strong opponents were more likely to be sellout games than the weak opponents, we do have an association here between whether the game sells out and the strength of the opponent. Now let's do the same thing with whether or not the Thunder wins. So if we look at the proportion of wins for strong opponents, it says that the Thunder won 4 out of these 22 games played against strong opponents. So 4 out of 22 is 0.182. And if we do the same calculation for weak opponents, the probability of winning here is 11 out of 19, or 0.579. So again, these are not equally likely. Knowing whether or not the opponent is strong gives you some information to predict whether or not the Thunder wins. So this is not surprising at all. When they play strong opponents, they're less likely to win than when they play weak opponents. In other words, yes, we do have an association between the strength of the opponent and whether or not the Thunder wins. So this is how we know that we've satisfied the definition of confounding, that we do have both of those associations. So let's write this out in words. So when the opponent is strong, thinking about the confounding variable here, when the opponent is strong, first we said that the game is more likely to sell out. So that sort of makes sense. People are going to be more interested in strong opponents, and so those games are going to be more likely to sell out. And the second part is that the Thunder is more likely to lose. So in this case, we're sort of setting up another possible explanation for this association. So maybe it's not that playing in front of a sellout crowd is necessarily a disadvantage. It's just that the games where they're playing in front of a sellout crowd also happen to be the games where they're playing strong opponents, and that's what makes them more likely to lose. So let's contrast this with something that would not be a confounder. Maybe something like whether players on the team are injured. Injuries could definitely make you more likely to lose, but they shouldn't make you more likely to sell out a game. If anything, less likely, because people might be less likely to buy tickets if they know that a big star on the team is injured. So in that case, you'd be talking about a variable that does have an impact on whether the team wins or loses, but it's not related to whether or not the game sells out. So it wouldn't be categorized as a confounder. In order to be a confounder, it has to be related to both the explanatory variable and the response variable.